Okay, so moving on in further into Unit 4, we are going to be looking at domain and piecewise functions today. Okay, so we're going to start off with domain, and we talked a little bit about domain whenever we were looking at whether things were functions or relations, right? But we want to go a little bit further into domain and some domain restrictions that we have. Okay, so domain, remember, is all possible inputs. Okay, so all things that can be put inside the function, okay, where the function is defined. Okay, so these are our allowed values, if you want to think of it that way. Okay, our allowed values. So there's a few things that we have to be careful with when we're talking about what is okay to put into a function and what is not okay to put into a function. And there's a couple things we have to be aware of. First is denominators. Okay, if we have a denominator that has a variable in our function, we have to be aware that our denominator can never equal 0. Okay, so we must exclude anything or any value that would make our denominator 0. Okay, so let's go ahead and write that. Must exclude values that make the denominator 0. Okay, so we must exclude any values that make the denominator 0. Okay, the other thing we have to be aware of is even root radicals. So remember when we talk about radicals, radicals is just the expression that has like a square root, a cube root, things like that. When it's an even root, we're assuming that this is an even number in our radical. Okay, so this would be like a square root or a fourth root or a sixth root. Okay, something like that. So remember, when we deal with radicals, whatever is underneath the radical sign is called our radicand. Okay, and when we have an even root, like a square root, our radicand, we can only simplify it if it happens to be a positive number, right? We can't take the square root of a negative. That gives us an I, or a complex or an imaginary number. So whatever's underneath here, we have to ensure that it's positive, right? So that we can simplify this. Or, well, we could have a 0 too, but we can't have a negative. So if we want to ensure that we either have a 0 or a positive, that they're not negative, then whatever's underneath our radical symbol has to be greater than or equal to 0. Okay, so basically what we're going to do is we're going to solve this, okay, whatever this little inequality equation is that we need to solve, and this gives us, this gives us the allowed domain. Okay, so we want to solve it, and that gives us the allowed domain. Okay, so if we have a denominator, we set it equal to 0, figure out what would make the denominator 0, and then we throw that out. Okay, if we have an even root radical, we take whatever's underneath it, we ensure that it be greater than or equal to 0. We solve this, and that tells us what values we can use for that function. Okay, so let's look at some examples here. First one, we're finding the domain, okay, and we always write our domain in interval notation. Let me write that back up here. Write in interval notation. Okay. All right. So interval notation is something that hopefully you've seen coming into this class, but if not, it shouldn't be something that's too terribly hard to grasp. Okay, so let's look at this first one. We're looking for the domain, which remember is all the allowed values. Okay, so I'm looking for the allowed values that I can plug into this. So I'm going to assume I can plug anything into it unless I have a restriction. This one I do have a restriction because I have an x in the denominator, and denominators cannot be 0. So that's the only restriction I have to worry about, is that the bottom cannot equal 0. So what I'm going to do is I'm going to go ahead and just set the denominator equal to 0 and solve for x, because then I'll know what x value would make the denominator 0, and I can just say, okay, well, it can't be that, right? So let's go ahead and solve this. So I'm going to move my 10 to the other side by subtracting. So I have negative 5x is equal to negative 10, and then I divide off my negative 5. So I get x is equal to positive 2. Okay, so what this is telling me is that if I were to plug a positive 2 in up here, it would equal out to where the denominator would be 0. So x cannot be 2. Okay, so x cannot equal 2. Okay, now I want to write my domain in interval notation. So I want to think about x can be anything from negative infinity to positive infinity except 2. So I have to take 2 out. So the way I'm going to write that is I can go from negative infinity all the way up to 2. But I can't include 2. So I'm going to use a parenthesis. Okay, remember brackets include, parentheses do not. So I'm taking out the 2. But then it could also be anything bigger than 2. So this little union symbol means it could be anything in this interval, or it could be anything in this interval. So I could be anything on the left side of 2, negative infinity up to 2, or 2 to infinity. Okay, so basically anything except the actual value 2. Okay, if it helps you, you can also put this on a number line. You can think on a number line, it could be anything except 2, right? So on this side, it would be from negative infinity up to 2, and we have to disinclude it because it cannot equal 2. And then it can be from 2 on out to positive infinity. Okay, and then we just put the union symbol in between. So let's look at another one. Same idea here. The only issues I'm looking for is if I have a variable denominator or if I have an even root radical. I don't have any radicals here, so I'm just looking to see if I have a variable denominator. In this case, I do have a variable in my denominator, so I know that this cannot equal 0. So just like I did on this last problem, I'm going to go ahead and set my denominator equal to 0 to figure out what values of x would cause this to be 0. Now, I could go ahead and factor this as a difference of squares and solve it that way, but since I only have an x squared term, I don't have an x term, I'm going to go ahead and solve this by using the square root property. So I'm going to move my 16 to the other side. So I have x squared is equal to 16, and then I'm going to take the square root of both sides. So the square root of x squared equals plus or minus the square root of 16, which means that x is equal to plus or minus 4. Okay, so what this tells me is that x cannot equal a positive 4 or a negative 4, because if I were to plug in a positive 4 or a negative 4 into this denominator, it would cause it to be 0, which is not allowed, right? So x cannot equal positive 4 or negative 4. So again, if it helps, you can write it on a number line. Here's negative 4. Here's positive 4. It can't be those things, but it could be anything else. It could be anything else on this number line. So anything that's smaller than negative 4 would fall into the interval negative infinity to negative 4, right? Not including. So we're using a parenthesis. Then it could also be anything between negative 4 and 4. So negative 4 to 4. Or it could be anything bigger than 4, right? So 4 to infinity. So this is the domain of that function. Okay? Kind of makes sense. All right, let's look at some that have radicals. So same idea with radicals. The only difference here, let me move this. Let's see if I can. I don't know if that made it better or worse. Maybe better. Maybe not better. We'll see. Stay tuned. All right, so we're going to look at some with radicals. So remember, with radicals, whatever's underneath our radical has to stay positive. So whatever's under here has to be greater than or equal to 0, right? It can't be 0. It just can't be negative, okay? So positive or 0. So I'm just going to take negative 4x plus 16 and set it greater than or equal to 0. And then I'm going to solve this. So I'm going to move my 16 to the other side by subtracting. Negative 4x is greater than or equal to negative 16. And then I need to divide off my negative 4. Now, I'm going to go ahead and put here, recall, because it's been a while since you've probably seen radicals, or sorry, inequalities. Okay, when we're solving inequalities, this sign stays the same, always like an equation, unless you multiply or divide by a negative. If you multiply or divide by a negative, multiply or divide by a negative number, what happens is the symbol flips, okay? Or the symbol reverses. Okay, so I'm just going to put this note here because I know some of you haven't seen inequalities since your last math class or potentially high school. Okay, but we have this rule that if you multiply or divide by a negative number, the inequality symbol flips or reverses. So when I want to go ahead and solve this out and I divide by a -4, that's going to flip this symbol because I'm dividing by a negative. So that gives me x is now less than or equal to a +4. Okay. Now, unlike these other ones that we worked where I just take that number and exclude it from all real numbers, what I come up with, this is actually my allowed domain. Allowed domain. Okay. So what this is saying is as long as I pick a number that's smaller than or equal to a +4, and I plug it in up here, then this will always stay non-negative. Okay, so this is my allowed domain. So this is saying any x's less than or equal to 4. So that means -infinity all the way up to 4 and including 4, so I can use a bracket, is allowed for this function. Okay, same thing if it helps you to graph it, you can make a graph and say, okay, well here's 4 and we can include 4 and it can be anything less than or equal to 4. So it would be this direction. Okay, so -infinity up to 4 and including it. Okay, let's look at another one. Same idea here. I have the square root of 6x minus 18 that I have to worry about, but I also have a denominator that I have to worry about, right? Now, normally here we would say this has to be greater than or equal to 0, but because it's in the denominator and denominators cannot be 0, I have to get rid of this little equal to bar. I can't let this equal 0 because it's in the denominator. So I'm going to go ahead and say, but the denominator cannot equal 0. Okay, so if the denominator cannot equal 0, then I cannot include this little equal to bar on this symbol. Okay, for this case, when the radical is in the denominator, we have to make sure it's strictly greater than 0. So we're going to go ahead and solve this as 6x minus 18 is strictly greater than 0 because we can't let it equal 0 because it's in the denominator and the denominator cannot be 0. Okay, so let's solve. We move our 18 over by adding, and we get 6x is greater than 18, and then we divide off our 6. Notice I'm not flipping the symbol here, okay? I only flip the symbol when you multiply or divide by a negative. Here I'm dividing by a positive, so I don't have to worry about that, okay? So I end up with x is greater than 3, right? So now I get x is greater than 3. If you want to think about that on a number line, whoops, here's where 3 would be. We're not including it. It doesn't have the equal to bar. And this says x is greater than 3. So it would be anything bigger than 3. So if I want to write that in interval notation, I'm starting at 3, but not including it. And then it can be anything bigger. So it's going to go on out to positive infinity. Okay? All right. So there are 2 on the next page for y'all to try. Find the domain and write it in interval notation. Okay, I'm going to give you a few minutes to work those. Go ahead and pause the video, and then when you're ready to move forward, go ahead and play it again, and we'll see how you did. All right, so when we look at the first practice problem, we only have a variable denominator to worry about, right? So we know our denominator cannot equal 0, so we just set our denominator equal to 0 to see what would cause it to be 0. We move our 21 over, divide off our 7, and we get x equals 3. So what that tells me is that I can't use 3, because if I were to plug 3 into this denominator, it would cause it to be 0. So if x can't be 3, then I have to take 3 out of my domain or out of my allowed values. So that means it can be anything except 3. So from negative infinity up to 3, not including, and then anything bigger than 3. So 3 to infinity. Okay. On the second one, same idea. Okay. I have a even root radical. Even root radicals cannot be negative, right? Because we can't calculate the square root of a negative number. So to ensure that it stays non-negative, we're just going to go ahead and set our radicand greater than or equal to 0. Now notice here I can include this equal to bar because this is not in the denominator. So it's okay to be 0. I move my 81 over by subtracting. I divide off my negative 9, which reverses the symbol. Don't forget to flip the symbol. So I get x is now less than or equal to 2. So it could be 2, it's included with the equal to bar, so we can use a bracket, or anything less than 2. So it's going to go down to negative infinity. Okay? And we always write our interval notation from the smallest number up to the largest number. So this is from negative infinity to 2 with a bracket. Infinities always have parentheses because they cannot include infinity, because infinity is not a number. Okay, so we always use parentheses on infinity. All right, so let's go ahead and look at another way to look at domain and range, actually. And that is when we are looking at a graph. So when we're looking at domain and range using a graph, our domain, again, is all allowed or defined values for x, okay, or our input, okay? And our range, and actually, if we're talking about all allowed values for x, x is the horizontal axis, right? This is our x-axis, this is our x-axis, this is our x-axis. So this is going from left to right, because we go from our smallest x to our biggest x. So smallest x to biggest, smallest x to biggest, smallest x to biggest. Okay. Our range is relating to our outputs or our y values. So this is all allowed or defined values for y, or our outputs. Okay. And our y-axis is the vertical axis, right? This is our y-axis, y-axis, y-axis. So if our y-axis is the vertical axis, we're looking from how far south it goes, right, to how up high north it goes. So let's say south to north. Or you can say up to down, however you want to, or down to up, sorry, because we do smallest to highest. So down to up, or south to north, okay? So again, we're going to write these in interval notation. So let's look at our first one. Okay, remember, open circle means it's not included. Closed circle means it is included. Arrow means it keeps on going. Okay, so when we look at this one, if we want to list our domain is our x value. So we're looking how far from the left to the right is it going to go. So to the left, it's starting at or stopping at 1, right? That's the farthest this picture goes, is it stops at 1. And at that point 1, it's not included. It has an open circle. So we're going to use a parenthesis to show it's not included at 1. And then we're going to trace along the x-axis. And notice my picture stops at x equals 4. So it's going to go over to 4, which is included because it has a solid dot. So we can use a bracket. Okay. And then let's look at our range. Our range is our y values. So I'm looking at my y-axis. How low does this picture go on my y-axis? Well, the lowest part of this picture is right here, right? And its y value there is 0. So 0 is my lowest y value, and I'm going to use a bracket, sorry, because it touches, it includes it at that point. Okay, and then the highest y value, or the highest that my picture goes over here on the y-axis, is this point right here, right? And that has a y value of 3. So it's also included because it has a solid dot. So this is going to be 0 to 3 with a bracket. Okay, let's look at the next one. Next one, domain is left to right. So I know how far this picture goes left to right. Well, it goes from this dot to this dot. So left to right is my x-axis. So the x value at this point is 0, and it's included because it's a solid point. And we go all the way over to this point. The x value at that point is 4, also included with a bracket, okay, because it's included. Now I'm going to do the same thing with my y values to find the range. My lowest y value is also these 2 points, right? Those are the lowest points on the graph, and the y value of those 2 points is at -2. So I'm going to include -2 with a bracket. And then from -2, my picture goes all the way up, and this is the highest point, right? And its y value is at +1. And we're going to go ahead and include it because there's not an open circle anywhere to show that it's not included. Okay. All right, let me look at one more, and then I'll have y'all try some. So on this one, domain, the farthest to the left this picture is going to go is this dot, which is included. It's a solid dot, and its x value at that point is -1. So we're going to include -1 with a bracket. And then the farthest to the right that our picture is going to go is this point, which is open, and its x value is at 4. So at 4, we're not including, so we're using a parenthesis. Okay. And then our range is our lowest to our highest y value. So our lowest value is this one, again, not including, but its y value is at -2. So we're not including at -2, and we're going to trace our picture as high up as it goes, which is this point, and its y value at that point is 1. So 1 with a bracket. Okay. All right. So these are our domain and range values for these 3 graphs. There are 2 at the top of the next page for y'all to try. So go ahead and pause the video, and then whenever you're ready to check yourself, go ahead and play it and see how you did. All right, so on this first one, our domain goes from -2 over to +2. The first 2 is not included because it has an open circle. The second 2 is included with a bracket because it has a solid dot. Okay, our range is our lowest to highest. So our lowest y value here is -1, and our picture goes all the way up to our highest y value, which is 3. 3 is not included because there's an open circle, so we use a parenthesis. -1 is included because we have a solid dot, so we can use a bracket on it. Okay. All right, on the second one, same idea. Left and right, our domain goes from -3 with a parenthesis because there's an open dot, all the way over to 4 with a bracket because it has a closed dot. Okay. And then our y values go from 1 up to 3, right? Because this is the lowest point on my picture, and this is the highest point on my picture. My lowest y value is at 1. Now notice at 1, it's not included here with an open circle, but it is included here, right? This line is defined at 1. So we should have a bracket at 1, and I don't. Silly me. Let's fix that. Fixie, fixie. All right. That's better. So even though this was an open circle at 1 because it wasn't included over here, because it's included at 1 over here, we're still going to include it on our range because it is defined at 1 at some point on our graph. And then our highest y value is up here at 3. And because it's a closed-in dot, we also have a bracket on 3. Okay? All right. So that is pretty much all of the domain type topics from this section.